let's kind of get started here. So the first thing I want to do is just kind of go through the test description. So the format for the test is here written in on today's notes. So you have one question where I ask you to describe the transformation. So I'll give you like the equation, and you're like, oh, it's reflected across the x-axis and, vertically stretched and shifted left 6 units or whatever, like that. I'll have 2 questions where I ask you to find the amplitude, period, midline, frequency from the equation. So again, we'll give you like the equation, and you just have to use your little formulas to figure out the period, midline, frequency, etc. You'll have one question where you have to write the equation for the sinusoid from a description, like we did in worksheet 4, I think. Is that the right number?
Yeah.
I think it is. Yeah, like worksheet 4. You'll have one question where you have to write the sinusoid from the graph. So that was like worksheet 5. And then you have 3 graphing problems. And those will be formatted similar to what you saw in the homework quiz, where I give you the equation, I give you the key points, and then a little place to write in your transform point for each of them. And then a space to draw your graph or whatever. Does that feel clear as to what I'm going to be asking you to do?
Yes, sir.
Rob.
Will the sinusoid questions only be sine and cosine, or can also be tangent?
So a sinusoid isn't a tangent equation. So sinusoid means sine or cosine only.
Okay, that makes sense. So the only tangent stuff is going to be in graphing?
Correct. Or the possibly like the period, midline, frequency, or like describe the transformation could be a tangent thing, but like to describe the transformation, does it matter what it is? No, like the sine, cosine, tangent, whatever, like it doesn't matter. Is that okay? So one thing to point out here that's going to be critical to really all of these questions is that you're able to like pick out the values for A, C, H, and K from an equation and know where the A, C, H, and K go back into the equation. If you can't do that, there's not a lot of chance you're going to get much of this right. Like that is a fundamental skill here that you just got to have on lockdown, or else problems come up. You know what I mean? Rami?
Cover like when you factor out, let's say it's like in parentheses after A, it's like 2x minus 4.
Yeah, hold on one second. I want to do this alongside with you, but apparently my stylus is being stubborn, and I'm going to try to just like pull the battery out and put it back in and see if that fixes whatever is ailing it. I don't know if it's starting to go or if it's just being dumb. Okay, so we have like y equals sine of, you said 2x
minus 4 for me. Just to show like the process of factoring it out.
Sure.
So once you factor out the 2, does that leave the value of C as 1? Because I know that's to get the H value, but does that fact that C is 1/2 then?
So yeah, so the standard transformation says that this value is 1 over C. So C then would be the reciprocal of 2, which is 1/2.
Okay, I don't know why I thought C was like directly attached to X in the original equation. I didn't realize that.
Yeah, it still is, right? This is still.
Yeah, but I thought it was like
that's still 1 over C.
Factoring to find H and then going back to the original to find C.
either place of looking is fine. It's going to be the same number, right? Because whatever was the coefficient on x is what you factor out. Whether you look at it in the original or in the factored form, it's still going to be the same number. So does that feel okay?
Yeah.
Joe, you had your hand up also.
Yeah. Can you go over the things that we have to memorize and the things that will be given to us in terms of the value? You know what I'm talking about?
Sure.
Okay.
So like, I think that, actually before I say anything, let me pull up on my other screen the actual document so I don't tell any roast beefs here. You know what I mean?
Yes, sir.
Say any roast beef?
Yeah,
What does that mean?
lies.
Haven't heard that before.
I don't know.
I'm trying to start using it.
That my wife says it that way. I don't know where she got it from, but I've inherited that as a saying that now I apparently say without even thinking about it.
I like it. I got this roast beef.
So like I'm going to give you this,
Okay, so
where f could be sine, cosine,
Yeah.
tangent, whatever.
Okay.
So like that's given to you.
Yeah.
So you don't need to really memorize that.
When?
From worksheet 1, this information here is going to be on there.
Okay, so we don't need to memorize those. Those will be there.
No, I would suspect you probably already kind of have them memorized,
Most
but
of them are. Some of them are.
that's on there for you.
Yes, I understand.
So I'm just going to call it that. That's okay with you guys. I guess let's be good here.
You don't
I
have
can-
to use it.
Yeah, it takes not a lot of time at all. I'll just do.
You listing what's going to be given or what we should
It's given. Yeah.
So basically that, right? See, that didn't take very long. So I'm going to give you the I'll give you those formulas kind of as they appeared in your tables and that we wrote in the notes. I'll give you the transformation map format. And then I'll give you the key points for whatever it is I'm asking you to graph. So I don't know what else you'd have to memorize. I don't know that I think that there's much left to do other
All of
than,
this is familiar
yeah,
with most of it.
right.
Okay, cool. Thank you.
But those things all be stated explicitly. If there's anything else beyond that, they're like, yo, I need to memorize this, that's on you. But
Sounds good.
that stuff would all be given explicitly on there at various places where the problem, where it's most relevant to that particular problem.
Thank you.
Okay, sure. These are reasonable questions to ask, so you don't waste a lot of time memorizing something you're given.
You know what? Can we do an example?
Yeah.
Is to the whole day review? Today.
Yeah, that's what we're blocked with.
Okay, cool. Can we do like one problem from each of the questions asked in the test? You know what I mean?
Yeah, sure.
Because there's only 1, 2, 3, 4, like 5 sections, I guess. We just do one problem for each section, kind of to like refresh.
Sure.
Thank you. It's a solid idea. You know what I mean? Get it in a notebook.
Let's do that. So let's describe the transformation. Let's say we do it for this one. So first thing I would do is I'd want to find my values for A, C, H, and K. Before I can do that, though, I need to make sure that I'm in that proper form. So I want to look at the inside part and check the leading coefficient on X. If that leading coefficient isn't 1, I'd want to start by factoring. I notice that it's not 1. So what am I going to be factoring off? 3. When I factor that off, I'm left with X minus what?
X minus 4 still?
Nope.
No?
4/3. Right? So you have to make sure that when you distribute the 3 back through, you should get 4 still, right? So if you have the 4 in the or the 3 in the denominator, when you distribute the 3 through, it just cancels out left with the 4. Okay. So my A is 1. My C is the reciprocal of 3. My H is 4/3 positive, and my K is 2. Okay. So I have those 6 transformations that I do. So the first 2 I do for C, A, H, and then K. So since C is positive, I have no reflection, so I'm just going to put a dash there, whatever. Since the absolute value of C is less than 1, that's a horizontal shrink by 1/3. Since the A is positive, there's no reflection, so I'll just put a dash there. And since the absolute value of A is equal to 1, there's no vertical stretch or shrink. Since H is positive, we're going right, and then 4/3 unit. And then since the K is positive, we're going up, and then since it's 6 units. Cool. Okay. Let's say we do the same problem, and we'll deal with the amplitude, midline, period, and frequency here all at the same time with the same example. Is that okay? So again, to do this problem, I start by obtaining the values for A, C, H, and K. We've already done that. So the amplitude is the absolute value of A. So in this case, that's 1. The midline is y equals K. So in this case, that's y equals 2. The period is 2 pi times the absolute value of C. So in this case, that's 2 pi over 3. And the frequency is the reciprocal of the period. So that's going to be 3 over 2 pi.
For the period, so what did you do with the 4? Sorry, okay. Did you just like cancel it out?
So what I did was I did 2 pi times the absolute value of 1/3.
Oh, times 1, sorry.
So I did like 2 pi over 1, multiply the tops and bottoms together. So far, so good? So that's all you have to do for that kind of problem. If we're just asking for like the midline and frequency and amplitude period, stuff like that. All pretty easy, right? Basically, if you can get the A, C, H, and K out of the problem correctly, it just, can you plug it into a formula? You know, there's not much to do there. Then, let's see, we'll grab one of these guys. So maybe let's do this one here. So this is going from a description to a sinusoid, right? So I'm going to start just by kind of drawing my picture of what's going on. So I'm just going to kind of sketch in my midline. And it says I have a minimum, And then I have my maximum up here. And I usually like to sketch in one full period, so I'm just going to kind of, maybe I'll just do that for the midline, that'd be easier. Dick, all right, be stubborn. So far, so good. First thing I like to do is find K. So K has to be halfway in between the Y coordinates for my max and min. So like halfway in between is the same as the median, the number in the middle. With two numbers, the median is the same thing as the average. So I'm just going to take the average of -12 and +8. So that's going to be -2. The A is the distance from one of these extreme points back to the midline. So here we're at 8 and we're going down to -2. So how many units did it take to go from +8 down to -2? 10 units, right?
Yeah.
We did 8 units to get back to 0, and then 2 more units down to get to -2. So 10 total units. So that's my amplitude. So that tells me the absolute value of A is 10. Okay. Now I'm going to look at my, find my value of C by looking at my period. So I know from here to here is 1 period, right? But I have just this section that I know about. How much of the period is the green part? Like a half, a third, a fourth? Looks like a half, right? You guys buy that? And a period is a horizontal distance, so I'm looking for this distance. So I'm looking at the x's. So how many units does it take to go from -6 to +24? Well, it takes 6 units to get to 0, and then 24 more units to get to 24, so 30. I can multiply both sides by 2 to get that 1 period is 60. And then I know the equation for a period is 2 pi times the absolute value of C. So I know that that's equal to 60. And when I divide both sides by 2 pi, I get that C is 30 over pi. And I'll choose to make C positive every time. Okay. So far, so good. The last thing that we need to do is decide whether we're going to use sine or cosine. Then we need to decide whether the A needs to be positive or negative, and then find the value for H. So first question, should I use sine or cosine for this problem?
Isn't it sine when it's a maximum?
It's not sine when it's cosine when it's max or min. So that would be something you probably want to memorize, right? So maxes and mins, we want to use cosine. So the point from cosine that we want to use is 0, 1, which is a maximum. Now I can match up that point with any extreme point for my transformed function. So we can use either the minimum at -6, -12, or the maximum at 24, 8. It doesn't matter. Both are fine to use. They're not really, one is not really any easier than the other. Which one would you like to use?
24 and 8, I guess.
Okay. So since they are both maximums, what does that tell me about A? Good. And since the parent function's x-coordinate is 0, what does that tell me about h?
24.
It's the x-coordinate from the transform function, so 24. And that's everything we need. So I have 10 cosine of 1 over c, so I'm going to write that as pi over 30, and x minus h plus k. Does that feel okay? All right. Here we'll go from graph to equation. So just like on the previous one, I'm going to find the midline first to get the k. I'm going to find the amplitude next to get my a. Find the period next to figure out c. Choose whether I'm going to use sine or cosine. And then find the sine of a and the value for h. So same process. Here, though, most of this I can do just kind of visually, right? So here I can identify the midline just by looking at this, right? That appears to be the midline. So that tells me that k is -1. I know that this distance is the amplitude, so starting at -1 and going up to +1 was how many units? 2 units. So absolute value of a is 2. Next we'll find the period. So the period is like maximum to maximum. So I'm starting here at 0 and going to pi. So my period is just pi. And remember the period is 2 pi times the absolute value of c. So if I divide both sides by 2 pi and choose to make c positive, I get c is 1/2. Still doing good? So if we want to use sine, I think this question asks to use both. I'm just going to do a both on the side. So I want to use the midline point, 0, 0. And from the parent function, that midline point is followed by a maximum. In this problem, I need to choose a midline point. So that's pi over 4 -1. That midline point, though, is followed by a minimum. Is that okay? What can I say about the value for a in this case?
You can still say it's positive, right? Or no?
Are they the same?
Well, they're both extremes. But does it have to be the same type of extreme?
Well, they're both midline points, but they have to be the same type of midline point.
Okay. So it's negative then?
It is negative, yeah. Unless they're identical.
Okay.
And then what can we say about the h?
Can we say h is pi over 4 or no?
Yep. Since the x-coordinate from the parent function is 0, which is why we're going to be careful about which one we want to use for sine or cosine. So that's that. If I'd used cosine, I'm going to use the point 0, 1, which is a maximum, which means that I have to pick an extreme point from over here. So I could pick 0, 1, or I could pick pi over 2, -3. It doesn't matter. Let's say we pick this one, just for grins. I think that's right. And that was a minimum. So what can we say about A?
Well, since they're not midline points, can we say that A is positive?
Are they the same type?
No, so it's negative still.
Yep. And the H is?
Pi over 2.
Yep. So you can say y equals -2 sine of 2, x minus pi over 2 minus 1. Or you can say y equals -2 cosine of 2, x minus pi over 2 minus 1. Either answer is fine. On the test, I'll tell you which parent function I want you to use, like which version I want you to write for this one. For the ones from a description, you're free to choose. But here I'll tell you which one I want. But they're really the same difficulty because you have freedom to choose any point from the graph. You always have a midline and extreme point, so it's not really, they're both easy. Yeah. And that's mostly just so it's easier for me to grade. Okay. So there's like only a few less versions of possible answers I would need to worry about seeing. And the last thing would be the graphing part. Right? I think we've done an example of everything else. So let's grab.
Oh, these were on the homework quiz.
Yeah, and the format for the test is going to be really the same that I would have for the homework, or as I had for the homework quiz. So let's say we're doing this one. I'm going to start by finding the value for A, C, H, and K. But I note here that I'm going to have to factor. You okay with how I factored that?
Yeah.
Riley? Of course. Wouldn't be class if you didn't. Ha ha ha. So the A is 1. The C is 1/2. H is -pi over 2. And K is 1. And so just like on the homework quiz, I'll have a place for you to fill in your transformation map. So it's Cx plus H, and then Ay plus K. And then I'll have the key points for you listed already.
And you just plug those into the XY formula?
Yes. And I'll have a blank for you to write your transformed point. So I'm just going to take my x and plug it into the x spot, and take my y and plug it into the y spot for each point. So that's just going to give me -pi over 2, 1. And then I'll have -pi over 4, 2. And then I'll have 0, 1. And I'll have pi over 4, 0. And then I'll have pi over 2, 1. So go ahead and graph this. So -pi over 2 is off my chart, but it'd be somewhere over here. -pi over 4 and 2 would be there. 0, 1 is there. Pi over 4, 0 is there. And then pi over 2, 1 is back there. So there's like one period. Is that okay with everybody? And then I would ask you to just kind of fill the space that's remaining. So I'm going to follow the pattern. So then basically just following the pattern starting from here. So I have a maximum and then a midline and then a minimum, midline, maximum, midline, and now I'm out of space. So I can just kind of connect things the rest of the way. Is that okay? Do you need me to do all the different types of graphs, or just like one Java good enough?
Thank you. Tangent graph.
Yeah, sure. Oops. Let's grab one of these ones. Okay. All right, let's see. So put it down there. Let's do this one, I suppose. So again, I'm going to start by finding the values for A, C, H, and K. I notice that I have to factor. What am I going to be factoring out? The 1/2. Right? Again, the way you check to make sure you did the factoring correct is if you distribute back through, you should get the same thing that you started with, right? It's easy sometimes to get turned around with the fractions there, but to try not to like overthink it. And then we'll write our transformation map. And then for my key points for tangent, again, we're just plugging the x's into the x spot and the y's in for the y spot. So negative pi over 2 times 2 is going to be negative pi, and plus pi is 0. And no matter what you do to the undefined, that stays undefined. I don't know why I put a 1 there. So negative pi over 2, or pi over 4 times 2 is negative pi over 2. Plus pi is going to be positive pi over 2. And then negative 1 plus 1 is 0. And this is just going to be pi and 1. And continuing on, 3 pi over 2 and 2. And then 2 pi and undefined. So looking at my graph, the undefineds tell me where my asymptotes are going to be. So I have an asymptote at 0, and I have an asymptote at 2 pi. And then pi over 2, 0, pi 1, 3 pi over 2, 2. And filling in the rest of the way, this little guy would be like there. I have low, middle, high, and asymptote.
Looks so different than I thought.
Yeah, it's just the same. Again, the key to remember there is the undefined piece, is where the asymptotes are. Worth pointing out to you on these problems, like where we're graphing, if you're like, oh, I'm not really sure if I got the right point or whatever out of this, what you can do is you can take your x coordinate from here, plug it into the function, and see if you're getting the correct y coordinate to come back out. To do this, your calculator needs to be in radian mode. But I can do like tangent of, I'm going to do the fraction here. So we're plugging in pi over 2. And then that's over 2 minus pi over 2 plus 1. And this should give me 0. So that looks like it's doing what it's supposed to. That's a nice check to make sure that I've done the arithmetic right. You can do the same thing for like this kind of a problem. So I can go and I can plug in my points into my answer and make sure that when I plug that x in, I'm getting that y coordinate to come back out. So I do 10 times cosine of pi over 30 times parenthesis -6 minus 24, double close my parenthesis, minus 2, and that should be giving me the -12. It did. And I should check both points though, because it is possible you get one that'll work and one that won't. So just doing the same thing, but instead of -6, I'm going to put in the 24. Make sure I got 8, which I did. So that's a way you can kind of check your answer to make sure. I know it's easy to make like a little arithmetic mistake on one of these things and get something wrong, but that's a nice easy way to check, right? It's fast. All you have to do is really type in your calculator and make sure that this x is giving you the correct y value. If it doesn't, then you can go back and go, okay, something's screwed up, and start looking for the mistake. Doesn't tell you what the mistake is, but it's helpful to at least know, like, okay, did I do that right? I don't know. Yeah, Jay, of course. Any more questions for me? Okay. If you change your mind, you can always let me know.